So onwards, we are now going to have a panel of folks who were there at the demo, led by Jeff Rulifson. Jeff, come on up here. And do we have some of your other panelists here?
I lost them in the audience. So,
okay,
Martin,
panelists.
Don,
So we've
Charles,
got
Christina.
Jeff, Don Andrews, Martin Hardy, Charles Irby, and then I think Christina's going to make a special guest appearance at some point. So please
come up now, Christina.
Come on up, folks.
So we're going to move from Gardner's eloquent talk about the what I call the Joe paper, the conceptual framework, into the sort of low-level bits and bytes.
So all of you who don't know, who here isn't a close friend to Jeff's? So let me explain to you, for those who are not, this is the I'm not real good at pool, but I like to play for money line. Yes. So yeah. Let's get your panelists up here. Come on up and have a seat.
Come on up. Yeah, I actually came in January of 1966. And Martin, when did you join us? When did you?
It was around, I'm not sure, but it was around just when he was moved to the new building and they were coming out.
Oh, so you were a little after me.
Yeah.
And Don was here before me.
October '66.
I think I was there. I had joined us.
No, October '66?
Then.
No, '65. Must have been. Christina,
we were
too long ago.
We were still in the wooden buildings.
Yeah, I came when we were right in between.
We'll get to Charles later, and I think Christina was in middle school. Was that right?
I was 13.
Yeah. Okay. So what we're going to do is just sort of try to set the framework of what computing was like at the time, what we had to build, a little bit about how we built it, what happened on the day of the demo, and then sort of what happened with the group as we went on after that. So one of the first, let's start way back when Doug moved from the conceptual framework paper to his first attempt at trying to get some augmentation for document editing. And he did that. He had a little control data machine called a 160A that I never programmed on. But you did some work on it, I think, Don.
I tinkered with what he called it the offline system. There was an offline system which allowed you to do editing by essentially making commands and a bunch of tape that got processed later. And the online system, which at that time there was an implementation, when I joined, there was an implementation on the CDC 3100 with, I think you've seen pictures of it in some of the reports, with one huge round display. And it was a dedicated system, that is one user on the 3100. And he was trying to promote the offline system as well, which was very difficult because they were structured documents. So if what you wanted to do is add some text to a document, that was fairly simple. You could create a punch tape that would then get processed and add that content to the document. But if you wanted to do some editing, it got very convoluted.
So let me go a little deeper. So the idea was that you sat at a Model 33 teletype and you typed control characters and text, and you created your document. And then when you wanted to edit your document, you would run this through the CDC 160A and you'd get a printout. And then if you wanted to edit the document, you'd take the printout, go back to a Model 33 teletype, and punch a new paper tape with editing commands to edit the paper document. And as Don said, you could add to the document, but I don't know that anybody could actually use it effectively to edit a document. It was quite confusing and very difficult. And then I came in January of '66. We had a CDC 3100, and not, I mean, barely a system that you could edit anything on, really.
It was mainly just a text editor, but it had structure to the files.
Yeah.
And that's the system they did the time and motion studies for the pointing devices on. They had several pointing devices I don't know if you were involved in any of them.
No, I wasn't.
There was one that worked under the table that was on your knee
Right.
and moved a spot on the screen, and another one that they had it was a commercially available light pen which you held up to the screen and pushed a button, and it sensed the cathode ray
Right.
synchrony.
So there's the famous NASA report on pointing devices. The project was administered through NASA, but was actually funded by Bob Taylor, that you saw the little video of. And it was a contract with Doug to try to figure out with NASA what kind of a pointing device one could put in a space capsule. And although the mouse actually sort of won all the tests for the fastest, most accurate movement, you couldn't have a mouse in a space capsule. So trackballs is what NASA adopted. And then right about that time, well, there was a small period after that where Bob Taylor had the idea of doing the 68 demo. And Doug would take me around the country to help sell this to other people associated with ARPA and ARPA program managers and whatnot. And I think we got approval for the 940 in late '66 or so.
That's when it got installed. That's about when it came on board.
Yeah, and then started bringing people like Martin in to get it to all go. And we had a pretty clear vision from a software viewpoint about where we wanted to go with this, which Don was a very big part of. You might talk about how the command meta language started. Then I'll tell him what that all
Let me
means.
give a little bit more background, because it all can be Googled and searched. But basically, at that time, computers were used for number crunching primarily, either like for using a space mission, computing orbits, or doing scientific calculations. And there was really no thought of using computers interactively or for anything other than maybe business computations as well as scientific computations. So the support for someone who wanted to do system programming was virtually non-existent in terms of development kits and compilers and support software. The tools that we had available, the 3100 system was actually written in assembly language and was a monolithic system that probably had features added on one by one and was very, very unworkable. So we, being young computer scientists who were trained in proper software construction and modular approaches and that sort of thing, basically we're faced with starting from scratch without a lot of set of tools to help us with that. So several of us were familiar with some work that we done at the Association for Computing Machinery Special Interest Group in LA, which had developed syntax-directed compiler writing systems, which we had experience with before we actually joined Doug's group. And one of the key things was a program called Meta2, which was a syntax-directed compiler that defined the syntax of a language that you wanted to create, and embedded in there were output instructions to produce the code to implement the action of that program that you wrote. And the key thing about this compiler is it was written in its own language, so it could compile itself. One of the striking things about this was the Meta2 compiler, written in its own language, fit on one page. So you could get your arms around it. It was hard to get your head around it, but you could get your arms around it. And it turned out that we began using derivatives of things that we developed based on that for control languages and software languages. And one of the stories about the command languages, one of my first days, Doug sat down with me and said, you see what we're trying to do here. We have a set of commands, and the user acts interactively with the computer. We'd like to be able to sit down and define that interaction in a very flexible way, to define what the commands are, the feedback, how you make selections, in a more formal way than actually writing the program to make it happen, so that we can develop new systems and experiment and do studies on them and so forth. And having messed with these meta languages and compiler writing systems, you know, when you have a hammer, the world looks like a nail. So I began to think, this is an application for a meta language. A meta language would define a set, it would be used to be able to define a set of command languages that you could use for different tools and subsystems in the NLS system. So we essentially created that command language. And one of the interesting things about that was, inadvertently and without really, I think, understanding the whole consequences of it, we separated the interactive and command part of the system from the actual functional part of changing the file system. Because in the command language, you sat down, you wrote the set of commands, and you wrote down how to make the selections. And at the end, you invoked a function to actually make that command take place. And that made it very easy later in our work to separate the interactive part and the actual functional part. And we had systems later on where that was actually implemented on separate computers. So you had the interaction very close on a high-speed computer, very close to the user, maybe smaller, and the larger back-end computer somewhere else would actually take care of the command execution. And you see that even today with browsers or smart applications running on your phone or your laptop, and the actual command execution and file storage is it's in the cloud somewhere.
So there's a whole, we could do a day workshop. Over the next 2 years, we started with this very simplistic Meta 2 system, and we built a Meta compiler. This was a compiler that would compile compilers. And we built programming languages then, compilers for programming languages. We built a special one for the SDS 940. We had the command meta language, and we eventually built the meta compiler up to this very powerful thing called tree meta. And using that system, bootstrapped from the 3100 to the 940 and got the demo going. It's a long story. Let's sort of move forward. So Martin played a lot of integral roles in in getting the hardware behind this going, because on the 940, you know, these were very, very primitive, very small, very slow machines, and the 940 was a time-sharing machine, and we could actually support, as I recall, about 8 people running on the 940, running NLS simultaneously. And so we had to do things like mouse tracking, which were just unheard of. And we had special keyboards that we needed interfaces to. And Martin had a lot to do with that. But there's one thing, there's one aspect. Well, you saw a little bit of the demo tape. So on the day of the demo, Doug was in the Civic Auditorium in San Francisco. And Don and I and one of our colleagues, Bill Paxton, were in the SRI engineering building in Menlo Park. And as you saw, the video conferencing was actually shared. So Doug could see me in a corner of the screen, and I could see him, and he could see what I was working on, or I could see what he was working on. And how that happened was sort of black magic. It's never actually been documented. So I'm serious. I could not find any write-up about how the video links worked and stuff like that. And I'd like Martin to actually talk about that a little.
Yeah, and
show your slide too, if you will.
But one of the things I wanted to say was that in the keyboard, the NLS keyboard, we actually added a meta key, another one that gave you the 8th bit, so you can expand the character words. So that was another addition. So I have some slides that show, that I've put together that show how everything was connected, the audio, the video, and the mouse and keyset, how they came up, back, up, and down, and we're up, okay. And what I wanted to say was, here's Doug in the middle, and when we did that demo, the result of that was this picture here. This is a standing ovation to Doug after the demo. And you can see how many people were there. It was a pretty big crowd. So,
I think there were about 2,000 people in the audience.
wow. I can put the picture up and you can count them. So this is a layout I did that has, over here in the left-hand upper corner is the different communication devices that were from San Francisco to Menlo Park. We had 2 modem systems up in the upper top here, and they were for voice and the mouse and keyset and keyboard information to go up and down that Doug had at his console. And then we had 2 data links. One was a downlink for Doug's face, and particularly, and to put on the screen of the machine in Menlo Park, and the other one was an uplink of the screen and 2 other cameras that mixed in for Doug and for Bill English, who sat in the background to communicate with. So I'll show you these diagrams so you can see the first. Well, let me go back here. I'll show you the mess of it all first. This one here. That was it. So, and then here is, before we go back, here's the 940. That's what it looked like in the front end and when it was all pretty. And back here is the interface for the mouse and keyset was this communication device, and that's Bill English looking at it. And we had there was a bunch of lights in the top where we tried to figure out things, what was going wrong. There were lots of things that went wrong all the time. So here's where we spent time. This is Ed Van der Riet and myself in those days, and we're trying to do all this wire wrapping, debugging that was on the back of the character generator, and that was always a nightmare. And the camera system, which we ended up with this is a setup when we first started. It shows you 2. They were a pair, and in the memory, it scanned them in pairs. If we go up to 16 was the ideal that it could handle, and it would do 2 by 2 by 2. It switched through, and the screens had a long persistence, so they would hold the image until it came back around and scanned again. And the character generator was one that we were in the analog world then, right? Basically, there was no ADD converters really, unless you made everything up out of resistors and stuff yourself. That didn't happen until it came out with the 4004 when they started doing it in Logic. And so the characters were drawn with resistors and capacitors that moved the current on the screen of the CRT to a position, and all that was done by the language, the program language that would know what the person wanted and put it in the right place, and then the character generator would draw it there. So Doug was able to have a code that he can move the text over to his different spot, and then we could fade in the image from down in Menlo Park. So that worked really well. So go back up here to the sound system. I mean the mouse and keyset. It ran through an interface box, which is a red box in the middle here, and down through the 1200 baud modems. And we thought that, well, Doug said, oh, 1200 baud is fast. You can't read faster than 1200 baud, 120 characters per second. That was kind of wrong. But now if we went back to 1200 baud, I'm sure everybody would get up and Google would be in big trouble. So that's what we did, and that worked quite fine in this particular case. And the voice system, which is we had so everybody can communicate, was pretty extensive. We had Bill English up in the back room behind the screen, running the monitor and stuff, and this was kind of what his command was, but this is at SRI. Stuart Brad there in his corner, and Bates over in the corner. So and this is where we practice. This was Bill's platform for practicing to do everything to make it all work. And we had the Idafor, which is the projector, which he borrowed and begged and borrowed and kept when we were supposed to send it back. And oh, that's the wrong picture. Sorry about that. And then we had the workstation down below, and there was a big room we had, and there was one of the sets that was here, and we could show it and display everything. And the Idafor was quite a machine. And then at the command center down there, there was me monitoring and a couple of other guys monitoring all the data stuff that was going around, and somehow it all worked. So we survived that. So thank you.
So I have.
And then the big thing was, any questions or?
Well, I have a question. We're gonna. I don't think we're set up for questions for the audience, but the link from this was all using microwave.
Yeah.
So
well, what I've talked about so far was the modems. They were just telephone.
Right. But the video links were all were microwave links.
Yeah.
And so you had to put a repeater in someplace in order to get line of sight down to San Francisco. Where was the repeater?
That was up on Skyline, so they were up in the hills so they can get that link to go up.
So we beamed from the SRI roof up to Skyline and then back down.
Yeah, and I don't depict that here. It's just I just show the one link going all the way down. But I do by showing that there's 3 connections. You can see the center one has the link in between, which means that that was a repeater of these 2 here.
So that's
yeah.
Go ahead.
Okay. So the way that worked is that it was pretty complicated. 50 years ago, trying to remember all this stuff, and hopefully I got it right. In fact, earlier during one of Bill's conversations, he couldn't remember either, and he thought we had 3, but we really only had 2 microwave links because we had these video mixers that could do everything basically. We had this one here, which got the signal from the display that Jeff had here in Menlo Park, and it also fed, and then that fed into a mixer which had connected to Bill's, which controlled the camera that was on the top of up high above Doug, so they can zoom in on the keyboard. And we had another camera on the side which could zoom into his face. And then the Idafor projector was fed from that on the live feed on the output. And Doug's screen was fed that way too. And then a feedback from that one camera went also back down to Menlo Park into another mixer that fed Jeff's screen, so they could fade in and out Doug's image in the background. And then Stuart was manning this camera, which we called the room camera, so he could scan all around the room. That would go up in the mixer. They could determine whether the face camera or the room camera was the dominant source going up to Doug. And when Doug said, switch it to the face, they would go to the mixer and change that over. It was preset, but it was basically the way that was. So it was kind of complicated, but it all came together and worked, which was quite phenomenal in itself. And then some of these guys we have here, let's see, go back to this guy. The sound system, over here. And by the way, what I'm using here is Doug's thing of hyperlinks. These are all hyperlink points that I've been picking up and showing the pictures, et cetera, the same concept. So yeah, it's kind of a tribute, I feel, to Doug, that this all kind of works. So, I don't know, is there any other questions? Or?
No, that's great. That's great.
Yeah.
Let's move forward.
Thank you.
So the video that you saw of Doug, there was are the screens, well, there was a video, not a video, a film made off the screens by just taking one of these video feeds. And it was filmed at SRI. And after the film was shot at 24 frames per second. And there were a couple of things that happened. I'll tell you about one of them. during the demo that have been lost. After the demo, I went around for quite a while showing this film various places, and we had a special projector made that you could stop it or you could run it in slow motion, and I could flick through the projector one film frame at a time without burning the film up. It was a pretty big deal. And one day I found a single frame in the videotape that showed that the system had crashed. And it used to crash so often that we worked with the guys at Berkeley and we put a lot of energy into very, very fast recovery. And so it would crash and it would recover very quickly. And if there was only one person on it, evidently it recovered in less than a 24th of a second. And that's a part of the history that's been lost now because the MPEG converters, when they went from video to this kind of stuff, have lost that frame. It's only in the film. Okay, so Charles, you were actually there.
Yes, I was in the audience, and I came in a little bit late, and the place was just packed. I recall standing along a wall because there were no seats left. As you saw in the picture that was shown a moment ago, it was quite a big room, and the Idafor was having quite a bit of difficulty. You can see it flickering, almost on the verge of failing.
Yeah, it was a big heat generator.
When you think about the state of the art at that time, in the late 60s, the fact that Ed and Bill English and others were able to put this all together, it's just astonishing. It's just absolutely astonishing. They don't get nearly the hardware guys don't get nearly the credit that they deserve to pull this off. Anyway. So I was at a point where I was working on a ground control system for a precursor to the Skylab. And at that time, just to give you a feeling for what user interface was like then, this was on a huge console, about the size of a small room, with a little display, and the keyboard had physical, what they called overlays that you plugged in on top. That's how you change from one set of functions to another. You plugged in a new overlay on the thing, and you push the buttons through the overlay. And that was the state of computing. That was advanced computing. Yeah. It was so advanced it never got actually completed. But I walked into that room with the context of what computing was at that point in time, which was essentially ballistics and business processing. That was kind of almost everything that was being done. And to see what Doug and his team had put together was just so mind-expanding. It's very, very hard to describe it to people. But what the effect it had on me personally was that I, immediately after the demo, sought out Bill English, since Doug had mentioned him in the session, and talked to him all about how everything worked, and asked him if he had any need for programmers. And about 2 months later, I was working there. So it was quite a remarkable thing. And again, I think it's just so hard. I came to Litton Industries, where I was doing this other project, from UC Santa Barbara, where I was working in Glenn Culler's computer research lab. And as far as I know, that was the only other interactive system that was in being at that time. The displays on this system were about the size of a suitcase with a little screen about that big. And all you could do was you could draw on it, arbitrary XY graphics, but you couldn't erase it. All you could do was wipe the whole thing clean and start over again.
Yeah.
What's that? Yeah, it was an Etch-a-Sketch, exactly. Electronically controlled Etch-a-Sketch. And so we did that, and we were very proud of what we had done. But that was the only thing I knew of that was anything even remotely like that. And to see the step from that to what Doug's team had done was just really amazing, just totally amazing. And I felt I just had to be part of it.
Yeah, sure, go ahead.
Yeah. I want to say, when Don was talking about those days when he was writing the compiler and it was a one-page thing, even in the 70s, early 70s, before the chips were dominant, people were writing code in assembly language. And I had split off from SRI, and Rodney Bondurant over here was working for me, and he was writing. He wrote a word processor, and I don't know if anybody remembers WordStar. We were doing indentations and stuff, and all that program doing the whole word processor ran out of 8-bit memory in a full one page. And at that time, they came out with a small disk. They were $1 a bit, so a 5K disk cost $5,000. So the NLS workstation sold for $5,600 a station, a workstation with a mouse. He said mouse was $200 or $250, I think, to build. All analog, because there was no, until the 4004 came out, you couldn't make a cheap, inexpensive AD converter. It was several $100s in a big box, and that chip was just a little dinky thing. And we piled them together to get 8 bits, and that worked for digitizing the mouse at that time. After this demo, when we came to the line processor and the PDP-10 to do the time sharing, where we can get a digital signal directly into the computer without having to do all this conversion. And so, you know, it was a big time. It was hard to do all that stuff because it was either binary or wires of resistors and transistors at that time. So.
Okay, so we only have 13 minutes left. Let's see. Yeah, let me clear that up. So the Fall Joint Computer Conference was officially held in Brooks Hall. And Brooks Hall is the large conference space above the parking lot in Civic Center in San Francisco. Across the street from Brooks Hall is the Civic Auditorium. So the official addresses of the Fall Joint Computer Conference was the Civic Auditorium. The demo was actually held in the Civic Auditorium. It's now called the Bill Graham Civic Auditorium. Before that, it was the Civic Auditorium. Before that, it was used for the opera or something in San Francisco. And before that, it was used for the Warriors basketball building. It goes way back into the 1930s. No, that's wrong then. It was in the Civic Auditorium. I know. I was up there many times before. The pictures in the film actually matched the stage in the Civic Auditorium. It was. Okay. The rest of the story is I had always called it Brooks Hall, and I thought it was actually in Brooks Hall. And there was another film that was made last summer about Doug and all of this stuff. And I went up with the film crew, because I'm in a lot of the film. And I went up with the film crew, and we got the property manager for San Francisco to let us into Brooks Hall. And he took us under the parking lot. And I said, oh, this isn't where the demo was. And so he took us across the street and showed us the stage. And then we had to go back and clean up the wiki pages and get everything historically correct. Okay, so I've used a lot of time in that. We have to skip the. So after the demo, with the group grew quite a bit, and they made a transition from the 940 to the PDP-10. And there's a long story about how that bootstrapping worked, because we had all these meta compilers and that compiled the compilers, and we had our own tool set, and they were able to map it over very fast. But the important thing I want to get to is how the group then made the system available over the ARPANET, amazingly enough, to user groups that ARPA sponsored. So would you talk about that a little bit, Christina?
Sure. I think, let's see, so in the group, so Dad's original idea was that to make the world a better place, that requires a collective effort, and so that requires organizations. And so the first prototype organization that would learn how to do that was the lab, because it turned out that when you're prototyping those capabilities you were prototyping, that you could be your own subject of the test. And that gave a really fast feedback loop and everything. But his idea always was to scale that out to networks and out to organizations. And so in 1967, when Bob Taylor at ARPA was announce, he brought his principal investigators together to announce that they were going to go ahead and do this ARPANET thing and that they would be sharing resources across these mainframes that were being funded in different places. And so the story is, and this is confirmed by Bob and my father, is that my dad was like, oh boy, that's great. And everybody else sort of backed up because they were like, why would we want to share our resources on our computer? So there was a big sort of tussle, but Dad was really adamant about that's exactly the way to go. And we could offer this, what we're doing and how we're working over the network, and also get out into more organizations. And so some of the first organizations who were using it were the funding organizations. So ARPA, and actually that's how I first met Vince Cerf, because he was using NLS at the ARPA office in the IPTO. And the Romero Development Center, which was also funding at the time, the ARPA agent there was using it, and they were trying to bring it into the organization. So Dad had this idea that to bring it into an organization, you don't just go put it out to everybody. You find the people who are going to be the ones to shepherd it in. They're the architects of how this change is going to happen in their organization. And so he went around to different users of or these change agents within the ARPANET community, because that was the network, and recruited a number of those change agents, which he called architects of this. And so he created a community of these architects, and this is the first networked user community and the first sort of improvement community of people who were coming together. They were all charged with advancing capability within their own organization. So they started collaborating among themselves on like, well, how are you going to do that? How are you going to do that? How did you get your boss to give you more funding for this? And what kind of training are you offering here? And so, really, and they were using NLS to collaborate this way. And then they got to come and have total immersion in the lab. They could come, and I think it was every quarter that they were coming, and to see what it's like. I mean, that's sort of the end result, is that this is how we could live and work together. We're going to just sort of piecemeal these capabilities into our organization. So Dad called that the Knowledge Workshops Architect Community, which is QUAC. And so they had every year elected a chairman to this committee, and the chairman was called the King Quack. And it was quite an honor to be the King Quack, and they loved being quacks. And there was always a portion of the meeting where the art group was not allowed inside, so they got to have their own private time to discuss among themselves what they would like to see that's different, and how, so they became part of the design process in an extended way. And so this is maybe one of the first sort of lean, customer-focused, iterative projects, all done online. And then gradually more users and more networks, TimeNet and other, I can't remember the other networks.
How many sites were there total?
They're all together, in the end, there were hundreds. And so, and this was all documented by one of the first users from the Romero Development Center, which I used, Dwayne Stone. He ended up writing a history of this. And so, and that's online at the Internet Archive. What year was that? So the ARPANET came online, actually that's another story in itself, between this group and UCLA, because this group was tasked to be the network information center for the new network because of the NLS and the interest in information, services. And UCLA was tasked to be the network measurement center. And so those two were the first to be brought on. So it was between UCLA and SRI, this group at SRI, to have that first transmission and get it working. Then so this is 1969, the end of 1969, there were 4 sites working. And then it expanded from there.
Okay.
And I think, so you worked with, and Steve Crocker is here in the room somewhere.
Steve Crocker, I think, is here someplace, and Vince Cerf is here.
And Vince Cerf.
And there was another colleague named Steve Carr at the University of Utah. And we started meeting and talking and arguing, and then eventually we started writing things down, and those memos became the RFCs, and the rest is history. let's see. So I want to make a little closing comment, but anything else before I do that?
Did you want to talk at all about the line processor and all we had to do to get it to work through the internet?
Yeah, well,
The ARPANET.
let me just do it very briefly. So there is a long discussion then about how they actually made this work over the ARPANET. Because what you wanted to do was have the appearance that you saw on the screen with interactive text manipulation and mouse movement and whatnot, operating through an extraordinarily low band version 0 of what grew up to become the internet. And to do that, they had to build gear to go remotely to handle the interactive processing part, and then the PDP-10s back at the home site would actually manipulate the documents. This model, I mean, you see it today, this is Gmail, exactly the way that it works. So let me go on. So I want to go back to a point that Don and Charles talked about a little bit. I was actually a graduate student all this time. I was in the honors co-op program at Stanford, starting work toward my PhD while I was doing all this stuff at SRI. And at that time, the computer science department at Stanford was actually a part of the math department. They weren't even a separate department yet. And computer science at that level, I mean, most of the computers in the world were doing inventory control, data processing, payroll, that kind of stuff. By far the majority of computers. Computer science was basically numerical analysis, logic, and metamathematics, proving that Klein T predicates are equivalent to Turing machines and this kind of stuff. So that was sort of the state of affairs in November of 1968. Bob Taylor, in his role at ARPA, was really the sort of an overall manager of a lot of the computer science research going on in the country at the time. If you go back and look in ACMs from 1968, I don't know, maybe half the articles are from people that had ARPA sponsorship. And so he had a very good handle on this, and he seeded the audience. He went to all his sites at MIT and CMU and Utah and Champaign-Urbana and UCLA and Santa Barbara and every place, and had them send people into this audience of 2,000. And we did the demo in December, and then I characterize it as, and in January, we had these evangelists, Taylor had these evangelists that just sort of flipped the bit in computer science from this focus on mathematics and metamathematics and logic over, I mean, that was still going to go on, but the huge flip into computers are really for communication and for getting people to work together by communicating. In Doug's case, text, a little tiny bit of graphics, and the video. Okay, so I think that's it. Thank you.
Thank you.